So I just realized I messed up yesterday's lesson on Circumcenter because you can hear me talking and you can see pretty much everything except for what I was drawing on that new program that I used. You'll see it here in a second. I figured out what my mistake was, and I'm going to reteach this lesson just in my room during my free period the next day. So let's try it again. So the first thing that we talked about was a thing called the perpendicular bisector. The perpendicular bisector is very important when we talk about the circumcenter. So let me draw a line segment. Let me change my little writing stuff. I know you can't see that, but all right, I think we're good to go now. So what I'm going to do is I'm going to put a line segment right here. And we call it anything. Just put a point right here, make it look like a point, and make a point right here. And what I want to do is find the perpendicular bisector. Let's write that down. Perpendicular. It's supposed to be an A. Perpendicular bisector. All right, so it has, we call it perpendicular bisector because it does these two things. It bisects this segment and it's perpendicular to it. So if I was to bisect this segment right here, that would go right where that dot is. And let me put a point right there. Oops, can't do that. Let's try that again. There we go. Right there. And then what we're going to do is make a line or a line segment, doesn't matter, line or line segment that is perpendicular to this segment. Let's call this AB. And we'll call this M for midpoint. That's an M. And we want to put a line or a line segment that is perpendicular to it. Let's just draw that in a different color. So I would start here and hit shift on my computer. Let's make it look a little more in the middle. There we go. And again, like I said, it could be a line or it could be a line segment. So we'll just make it a line right now. So we got a line. So what is this yellow line right here? This yellow line is the perpendicular bisector because it hits the midpoint, which means this little segment AM and this little segment BM are equal to each other because this is the midpoint. So my yellow line bisects it. Bisects means it goes through the center, the middle, okay? It splits it into two equal parts. So it bisects it and it's perpendicular. So I made it perpendicular. Now I know it's perpendicular by putting that little right angle mark. So that's a perpendicular bisector. That's pretty important for what we're going to do here in a minute. So let me switch over to, let's make sure I do this right. Click off of that. There we go. Now I'm using the right program, and now you can actually see the triangle. Actually, I'm going to get rid of this triangle. Delete it. There we go. Oops. Let's delete. Let's just move everything. Going crazy. Let's move everything out of the way. There we go. Okay, now we start from scratch. So what I'm going to do now is I'm going to use this program. It's a new program. It's not new for me, but it's been around for a while. But for this class anyway, it's a new program. It's called GeoGebra. And you see the geo, which is like geometry, and the jabra is kind of like algebra. So you can use this program for algebra and geometry. So what I'm going to do is do a perpendicular bisector with this program because I was a little limited on the other program. You'll see how cool this is. So what I'm going to do is I'm going to draw a segment. So over here on the left, you see that segment. I'm going to click a point right here, click a point right there, and I've got a segment. And this program is super cool because now I can actually put in a perpendicular bisector. And it even named these points. I didn't even have to name them. They named them by themselves. So if I come over here and click on perpendicular bisector and then click on this line, what it's going to do, it's going to find the middle of this line segment, the midpoint of this line segment, and it's going to give you a line that keeps on going. You'll see that it keeps on going forever and ever. That is perpendicular at that midpoint. So all I got to do is just click on this line, and then there it is. That's the midpoint of this segment, and this line is perpendicular. It doesn't show the right angle mark, but it is perpendicular. Just take my word for it. It's perpendicular. What I can do with this is I can put a point and then click right there. So that's the midpoint. We'll call it F. That's our midpoint. And that's a perpendicular bisector. So what do we care about the perpendicular bisector? Well, we have something. Let me see where it is. Yep. It's the first theorem. It's on 5.1 and it's on 206, page 206. If you look at it, I'm not going to write out the whole entire thing, but let's read it. And then I'm going to explain what it does. It says, a point lies on the perpendicular bisector of a segment if and only if it's equidistant from the endpoints. Let's take the first part. It says, a point lies on the perpendicular bisector. Well, this point lies on the perpendicular bisector, but let's put another point. Let's put a point like right there, okay? So that point, I believe, yep, that's right on the perpendicular bisector. So we have a point right there. And the theorem says, if you have a point that lies on the perpendicular bisector, it's equidistant from the endpoints. What does that mean? That means that point G is equidistant from the endpoints of that original segment that we drew. So from G to D must be the same distance as from G to E. Well, let's actually draw a little segment. So let's go from here to here, and then let's do another one from G to E. And in fact, I believe that we can right click on it, I think. Is it? No, I think we just, oops, sorry. Gotta escape that. If I click on that, there we go. I can actually change the color of it. Let's make it red so it stands out a little bit. Let's click on this one and make that red. I just want you to see the difference between these two and our original. All right, so those are the lengths. Remember what this said. If a point lies on the perpendicular bisector, which G does, then it's equidistant from the endpoints of that original segment. So from G to D is the same distance as from G to E. Another cool thing this program does, it'll actually tell you what the length is. So if I click on this button right here, it says distance or length, and then I click on this line, and then it'll give me a distance. It's 8.2. Oops. Let's just, let's say, oh, I gotta hit escape, sorry. I'm just learning this program again. I used to use it a long time ago when I was teaching math, but now I've got to relearn it. So I'm going to click on this. It'll give me, oops, got to click on distance or length. Click on this line right there. There we go. And now let's move this out so I can see it a little bit better. It's 8.2. It's not like inches or centimeters. It's just some arbitrary unit, but it's 8.2. And you can see that both of these, I didn't like type in 8.2. It told me that this length was 8.2. And it told me this length was 8.2. Now, why is that true? That's true because if you have a point that lies on the perpendicular bisector, it's equidistant from the endpoints of that segment. What's cool about this program is I can take that point G and I can move it around. Actually, that wasn't actually right. See, that looks like it's off. But if it's right on, I kind of messed up that a little bit. But if it's right on the perpendicular bisector, then it's going to be equidistant. Watch this. If it's not on the perpendicular bisector, then it's not equidistant. See, that's 7 and that's 8.8. So I can move this anywhere. If it's not on the perpendicular bisector, those lengths aren't going to be the same. When are the lengths going to be the same? When it lies right on the perpendicular bisector, like right there. Okay? See, that's 6.2, that's 6.2. So that's kind of cool, and it's kind of cool that this little program does that. It's on the perpendicular bisector at 7.5, even if we make it a little closer to the midpoint, it's still the same distance. If I put it right on the midpoint, there you go, it's 5.6, which is kind of cool. All right, let's see if it really is the midpoint. So what I could do, let's see, click on distance or length, and I'm going to click on that segment right there, and there it is. 11.1 is the whole thing. And if I take this, oops, gotta hit escape. If I come over here and hit this and put it right there, put it right in the middle. Anyway, there you go. It's looks like 5, and it depends. There it goes. So that's right in the middle. I know it's 0.2, but it all depends on the rounding. I could change the rounding. I'm not going to do that, but that's good enough. All right, enough of that. Let's see. How do I get rid of the whole thing? Maybe this. Oh, that just undoes what I just did. I'll tell you what. I'm going to get rid of this line because that line. If I take this and hit Control minus, see that keeps on going forever and ever and ever. and I don't want it to do that. I think there is a way that I can just delete everything, but I'm not going to use this time to figure that out. I'm just going to scooch this up to the top. Now it's going to use those same, it's going to continue with the letters, so we're just not going to start at A and B, but that's good enough. All right, enough of that. Let's do this. Let's talk about what we wanted to talk about to begin with, is the Circumcenter. Now, what we just finished doing is really important to what we're going to do next, because it has to do with what we're going to do. So first of all, I'm going to put a triangle in here. So if I hit polygon, I click here, and then come back to the beginning. There, I've got a triangle. I can, oops, don't want that, escape. I can move this triangle around. I can change the shape of it by grabbing the corner and see how it changes the shape, which is kind of cool. Grab this vertex, and it only changes the two sides that make up that vertex, but that's good enough. All right, that's nice. There's a nice triangle right here. What we're going to do is we are going to find the perpendicular bisector of all three of these sides. So that's why we did perpendicular bisector earlier. So what I'm going to do is come over here, click on perpendicular bisector, click on this side right here, and there's the perpendicular bisector. It splits the middle, so from F to H, that's the midpoint of that segment right there, that side of the triangle. And it's perpendicular because it's a right angle. It doesn't show the right angle, but that is a right angle right there. So that's kind of cool. Let's do it to all three of them. So I did the perpendicular bisector of this side. Let's do the perpendicular bisector of this side. So let me click on that. There it is. All right, so they intersect right there. Now, what's really cool, and in class we did this, but on the video it didn't show up because I was dumb and I messed up, okay? But in class, we clicked on this third one, and we saw that the perpendicular bisector, it's really interesting because it does split the middle of this segment right here, but it actually goes through this point right here, which I think is kind of cool. So if I click on this anywhere on this side, if I click on it, and check it out, that perpendicular bisector hits right at that point right there. And what I'm going to do is I'm going to actually put a point right there, okay? Now, if I move this thing around, look what happens. Isn't that cool? They all stay together, all right? So it doesn't matter what shape of the triangle is. See, I changed the shape of the triangle, but this thing right here is still the perpendicular bisector. It still hits the middle, and it's perpendicular. Still hits the middle, it's perpendicular. Right here, it still hits the middle and it's perpendicular. But that right there, this point right here is called our circumcenter. So I believe I can change it. And I'm going to actually write in the word circumcenter. Let's see if this works. Yeah, it does. All right, so that's the circumcenter right there. I can move this around if I want to. And whenever I move it, it still tells me it's a circumcenter. Now, what's kind of cool about this is watch this. If that lies right on there, then this angle, let me get it right on there, it's close enough. This triangle right here is now a right triangle. Do you see it? From F to H and H to I, that's actually a right angle right here. So when your triangle is a right triangle, your circumcenter is going to lie on the hypotenuse of the right triangle, which I think is kind of interesting. All right, so when you have a right triangle and you draw the perpendicular bisectors of all three sides, your circumcenter, the point where they are concurrent, okay, remember that word, the lines are concurrent because they all intersect at the same point. That circumcenter right there is going to be right on the right triangle. Now, what if I did this? What kind of let's scooch this down a little bit. It's kind of getting in the way of everything else, but that's okay. Let me move this down like that. There we go. Right. What kind of a triangle do we have now? This angle right here, and I'll tell you what, I can actually, let's see where I do this. Angle, that's what I mean. So if I click on the angle, it'll actually tell me what that angle is, which is kind of cool. So if I click this side and this side right here, it actually tells me what that angle is. And that's kind of, I'll put it right here. There you go. It's 105 degrees. So that means this is an obtuse triangle. Now, when it's an obtuse triangle, the circumcenter lies on the outside of the triangle. Okay, this whole thing is, as long as that's more than 90 degrees, then I've got an obtuse triangle. And that circumcenter will always be on the outside of it. Once I make it 90 degrees, let's see if I can make it 90 degrees. degrees. Yep, right there. There's 90 degrees. If it's 90 degrees, where does the circumcenter lie? It lies right on the hypotenuse of that right triangle. What happens if I make this an acute triangle? So if I make it less than 90, oops, let's go like this. There we go. If it's less than 90 degrees, do you see that angle right there? So all three of these angles are less than 90. The circumcenter lies inside of the triangle. So that's pretty cool. I like that. All right. Let's scooch this up just a little bit. Now, that's not the only thing that's cool about the circumcenter. There's one thing that's really, really, I think, kind of interesting about the circumcenter, and it's this. The distance, and we have a theorem that says this. It's on page 207. It's called the circumcenter theorem. How about that? It says that the circumcenter is going to be equidistant from the vertices of the triangle. What in the world does that mean? This circumcenter, this point right here, is equidistant, the same distance from all three of the vertices of that triangle. So let's do it. Let's actually put a segment from the circumcenter to point F. All right, and we'll color those in a second. And then we're going to go from the circumcenter to point I, and then we're going to go from the circumcenter to point H. Let's see if I can get it right there. I think I'm on there. All right. And if I move this around, yeah. And let's change the color of these. So if I make this, let's make it red again. And this, we'll make that red, just so they stand out a little bit, because there's so many lines flying all over the place here. I'm just going to make it a little easier to see with the red. There we go. Okay. Now, what does this thing say? It says it's equidistant. So all three of these red lines, no matter where or what kind of shape I make this triangle, okay, what kind of triangle it is, whether it's 90, whether it's 90, whether it's obtuse, or whether it's acute, all three of those red lines, they look like they're the same length. Let's see if they really are or not. And I can check that on this program by going to this thing where it says distance or length, click on it, click on this red one. That's 12.6. Hopefully, click on that red one, it's 12.6, and click on this red one, and it's also 12.6. Check it out. So that shows you for a fact, well, at least according to this program, if the program's right, that the distance from the circumcenter to each one of these vertices is exactly the same. It doesn't matter if it's an obtuse triangle. Look at it. They're all 13.4. And as I move it, you see the numbers changing. All right, so they change lengths, but they're all the same every single time. Those red lines right there are all the same. It doesn't matter if it's a right triangle. Let's get it. Try to get it right at 90 if I can. Right there. There's 90 degrees. So they're still the same, 12.3. If I make it an acute triangle right here, see 72.4, so it's an acute triangle. So what's true about those three lengths? They're still all the same length, which I think is pretty interesting. Let me see if there's anything else I need to talk about. I think that's it. So that's pretty much it with the circumcenter. All right, so hopefully this program helped you understand it a little more. It's kind of fancy, but hopefully it lets you understand what's true about the lengths. So how do we find the circumcenter? This is what you're going to be asked. You're going to be asked this on a test. How do I find the circumcenter? You find the perpendicular bisector, the perpendicular bisector of all three sides. So this line right here is a perpendicular bisector. I'll tell you what, let's change those, put those in color, let's make it green, all right? This right here is a perpendicular bisector. Let's make that green. And then this one right here is a perpendicular bisector. So all the green ones are perpendicular bisectors, right? If you're not really sure if they are or not, watch, I can do this. I can go to angle again. So click on angle. I'm not going to do this to all three of them, but I'll do it to one of them. So if I click on this, click on that, boom, there it is. There's your 90-degree angle. It even puts the box there. I tell you what, I changed my mind. Let's do all of them. So there's a 90 degrees just to make sure you see it, and that's 90 degrees as well. So those are all perpendicular bisectors. It hits the midpoint. So this point right here, I didn't put a letter there or a point. I could have, but that would be the midpoint, that would be the midpoint, and that would be the midpoint. All right, and so that's a perpendicular bisector. And what's true, what happens they all intersect each other at one point. They're all concurrent, and they intersect at a point called the circumcenter. So that's the circumcenter. Now we have a relationship between the circumcenter and the triangle. That relationship is that the distance from the circumcenter to each one of the vertices is exactly the same. So that's kind of cool. So we didn't make it the same. All we did was figure out the perpendicular bisectors. So they all intersect at one point, and they're all the same distance from the vertices. I think that's kind of cool. I don't know if you do or not. I do. I think it's kind of neat. So that's it. That's all there is. I'm not going to give you any homework today, tomorrow. Actually, tomorrow is today. This is as I'm teaching yesterday. But anyway, I will give you some homework, just not right now. And that's it. I hope that makes sense. And I think it all showed up. Yep, it did show up. And that's it. A little quicker than I did in class. And this way, at least you could see what I was doing. So I think I'll keep the other video up, but I'll put maybe a little disclaimer on it that you don't see the graphics. But this one actually does work. All right, enough of that. We'll see you next time.